Good morning. My group is composed by Laura Sofía Aldana Sánchez, Valeria Vargas Amaya, Laura Stephanie Castro Galvis, Britney Lorena Olivares Anoca, Carlos Andrés Gómez Jiménez. Our project is about water purification by electrocoagulation. Theoretical framework. What is water purification by electrocoagulation? Electrocoagulation is an alternative method of water treatment. It consists of the destabilization process of the contaminants in the water. Whether they are in suspense, emulsified, or dissolved through the action of low voltage, direct electric current, and the action of sacrificial metal electrodes, normally aluminum iron.
How does electrocoagulation work? The electrochemical process electrically oxidizes a galvanic anode, main component used to protect metal structures from corrosion. To release metal ions that form coagulants destabilizing contaminants and breaking emulsions. This coagulation forms fragments that flow to the surface for removal. The process traditionally utilizes an anode and a cathode, stimulated by a DC, that means a direct current power source to destabilize the charge. This operation separates fluctuating materials from water, allowing those materials to be removed, leaving clear water. It involves the distinct stage that incorporates chemical and physical phenomena. Stage 1. Electrolytic oxidation. In situ formation of coagulants. Stage 2. Destabilization of contaminants, emulsions, particulates. And stage 3. Flux formation.
Good day. What is chemical electrocoagulation? Electrocoagulation is an alternative method for the purification of wastewater. It allows the elimination of contaminants, oils and fats, heavy metals, colloids, organic molecules, colors, among others. In suspension dissolved of emulsified from very diverse wastewater coming from of the electroplaning, food, papers, litters, steel and textile industries, as well as laundries and water production plants for humans consumption, among others.
Which chemical reaction occur in the electrocoagulation process? During electrolysis, a series of physical and chemical processes take place that allow the removal of contaminants from the electrolyte. A series of reactions occur at the electrodes that provide both positive and negative ions. The anode provides metal ions. This electrode is known as the sacrificial electrode, since the metal plate that forms it dissolves, while the plate that forms the cathode remains undissolved. The ions produced have the function of destabilizing the charge of the pollutant particles present in the water. When these charges have been neutralized, the system that holds the particles in suspension disappear, allowing the formation of aggregates of the pollutants and thus initiating the coagulation process. The ions provided by the electrodes trigger a process of contaminant removal that can occur in two ways. The first by chemical reaction and precipitation, and the second by physical processes of colloid aggregation, which depending on their density can float or precipitate. The most important reactions that contaminant particles can undergo are hydrolysis, electrolysis, ionization reaction, and free radical formation. These reactions change the properties of the water pollutant system, which leads to the removal of the pollutant load from the water.
Okay, now I'm gonna talk about the physiochemical parameters of drinking water and domestic wastewater. First, I'm gonna give the concept about drinking water and domestic wastewater. Domestic wastewater is the product of the use of liquor in different activities of household, which produce a level of water pollution. And the drinking water is a necessary for all people. It is not only used for drinking but also utilized for a food preparation. Now I'm gonna give the physiometric characteristics. To determine the classification of water, the physiochemical parameters of the water are used, which are not absolute indices of the contamination. In this case, the deviation from the norm must be measured. The most important physiometric parameters are pH, soluble solids, total suspended solids, turbidity, conductivity, nitrates, iron, and phosphates. Within the parameters provided by the WHO within the following. First, for the drinking water, we have a pH to 7 to 7.5, and for example, the turbidity is the 1 NTU, and soluble solids, total spent solids are less about 5 milligrams per liter, or the total spent solids are less by 200 milligrams per liter, and the conductivity um, is up or 2,500 microsiemens per centimeters. And now the domestic wastewater is have a pH bit less than 7, and the soluble solids um, are greater than 5 milligrams per liters, and the turbidity is letter as greater than 1 NTU. The nitrates are greater than 0.5 milligram liters, and the conductivity are in between 500 and 1,500 microsiemens over centimeters. This is the most important parameters on the water. We have more, but this is the most important. Now I gonna have the question problem that is it is possible to make domestic wastewater drinkable by electrocoagulation, and next to this we have the general objective that is evaluate whether it is possible to make domestic wastewater drinkable through electrocoagulation. And our specific objectives are identify the characteristics that allow the electrocoagulation method to make the wastewater drinkable. Second, determine what special characteristics are needed to develop a home electrocoagulation system. Third, compare the difference between developing an electrocoagulation system at industrial level and at home level. And fourth, justify why the electrocoagulation method is a good idea to implement the housework. And this is our reference for the theoretic mark. Thank you, teacher.